All right, everyone, we are going to do a quick walkthrough of graphing linear equations, meaning graphing straight lines. And there are four basic steps we're going to go through here. First is how to identify each of the different types of equations that we use. We have three different types, and we need to know how to identify them in order to know what method we should use. Each type of equation has a pretty standard method that we use with them. There are alternative methods sometimes, but we're just going to focus on standard method for now. Then we'll hit on some unusual cases and what happens in unusual situations in each of our three different types of equations. Then we'll talk about how to double check. First step, though, is identifying the type of equation you have. We have three different types. One is standard form, which typically looks about like this. The next is slope-intercept form, which typically looks like this. And finally, we have point-slope form, which typically looks about like this. So the way that you can identify each of these, standard form will be the form that has x and y both on the same side. Okay, so see how those are both on the left side of the equal sign? That's how you know it's standard form. Slope-intercept form will always have y completely by itself. Okay, so like it'll be just y equals. And if your equation starts with just y equals and then your x and usually another number are over on the other side, that's slope-intercept form. And then point-slope form, y and x are on separate sides, but they each have a number with them. And the x, the number that's with it, is in parentheses. Okay, and that's how you kind of tell the difference between our three types. What we're going to look at is the basic method now for each of those. So first we'll look at standard form. So 3x plus y equals 5 was kind of our example equation here. Okay, so we'll talk basic method there. And the basic method for standard form is to just simply find solutions. That's what you're doing when you graph anyways, graphing the solutions. So your goal is to just simply find numbers that you could plug in for x and y that create a true equation. Easiest way to do this is to rewrite your equation without the variables, to actually put physical blanks in for each of those variables. So I've put 3 times blank instead of 3x plus blank instead of plus y equals 5. Okay? And then we just simply need to find some solutions that work, and typically we will put those solutions in a little t-chart. Okay, so I'm making that right now. We'll put our solutions down there, and then we'll put them on our graph. So remember, trying zeros is always a good thing to do. So if I put in a 0 for x and a 5 for y, that works, right? 3 times 0 is 0, plus 5 is 5. So I'll stick those down here. 1 and 2 will also work. 3 times 1 is 3. Plus 2 is 5. That also makes the equation true. So 1 and 2 is an answer. And then typically we like a third one. You don't need a third one, but it's good to have something that can kind of confirm it. So I'm going to say 2 and negative 1. 3 times 2 is 6. 6 plus a negative 1 is 5. So 2 and negative 1. Put that down in our chart over here. And then all we're going to do is put those 3 different ordered pairs on a graph. So 0, 5 means 0 on the x-axis, 5 on the y-axis, which would be right here. 1 and 2 would be 1 on the x-axis and 2 on the y-axis. So that's right here, because there's our 1 and there's our 2, right? Okay. And then finally, 2 and negative 1 would be right here. And what we can kind of tell is that those make a, at least fairly, straight line. Okay, so we connect those with a straight line and put some arrows on the end. And that's our basic method for graphing in standard form, is just simply finding solutions. Slope-intercept form, we have y equals 1/2 x plus 3. When you're in slope-intercept form, your equation gives you information about the line, okay? Whatever number is before x is your slope, and whatever number is at the end here is your y-intercept, okay? You need to start with your y-intercept because that's a specific location. It's telling you that that's an answer. Okay, a y-intercept of 3 is an answer to that equation. So you should graph that first. Y-intercept means simply where it crosses the y-axis. Okay, so that's on our graph. And then you use the slope of 1/2. Slope can be described as either rise over run or change in y over change in x. Okay, so from there, I would rise 1 and run 2. Rise 1, run 2, make a dot. Rise 1, run 2, make a dot. Okay, positive slopes always go up and to the right. Finally, we're going to talk point slope form. So we had y minus 3 equals negative 2/5 x plus 1 in parentheses. I believe I got that right. I did. So this one, you find your starting point by taking the opposite of what's with x and the opposite of what's with y. You're basically trying to figure out what would I plug in for x and y to make both sides equal to 0. Okay? So I'm going to start my graph at negative 1, 3, which is right here. And then once again, I use my slope. It's negative 2/5. A negative slope will either go down and to the right. Will go down and to the right. Okay, positive is up and to the right. Negative is down to the right, so I go down 2 and over 5. And you could do that as many times as you want. Connect them with a line, and you are all set. So that's the basic method for each of them. Okay, with standard form, you're finding answers. Slope-intercept form, you're graphing the y-intercept, which is always that last number, and then using the slope to make more points. In point slope form, you're finding that initial starting point by figuring out the x and y that would make both sides 0. So in this case, it's opposite of x, opposite of y, right? Negative 1 and 3. And then you're using the slope to make more points there as well. So then the next thing that we would want to look at is just some unusual cases. Honestly, with this, with standard form, there really are no unusual cases. As long as it's in standard form, you're always just finding solutions. There just are situations where it's more difficult to find answers. Some of the strategies we talked about, again, please write out the equation with some blanks in it. I do think that makes it easier, along with using something that you can erase, right? So you can try putting in numbers and guessing and checking a little bit, okay? If you ever get stuck, plug in a number for one of the blanks, right? Like if I plug in, 1 for here, I mean, we have this solution already, but like if I just throw a 1 in there, excuse me, if I just throw a 1 in here, then I can just be like, okay, well, 3 times 1 is 3. Plus, what would get me 5? Oh, 3 plus 2 is 5. And that's not getting multiplied by anything, so I'm all good, right? It's easier sometimes to put in numbers, okay? But that's about the only advice I have there. For both of our slope-based ones, okay, so the one I have in orange and purple down here, point slope and slope-intercept form, the slope itself is typically where things will get super weird. So as an example, we could have a whole number slope, so maybe y equals 2x plus 5. In that particular situation, if you have a whole number slope, the issue is that slope is supposed to be a fraction. It's supposed to be rise over run, or change y over change in x. You can fix that by putting it over 1. That's for any whole number. And then the only other thing that can get a little bit weird is what if it looks like you don't have a slope, right? So here, I've got a y-intercept of negative 3, but it looks like I don't have a slope. Remember, the number that can be put before x without changing anything is a 1. So your slope would actually be 1, and I need it to be a fraction, so I'd make it 1 over 1. All of those same things could be true over here as well for that slope. The slope is where it kind of gets weird. The only other thing I can think of that might be a little odd for specifically slope-intercept is, what if I don't appear to have a y-intercept, right? In that case, you would assume your y-intercept is 0, because adding 0 would not change the value of the equation. So if you see y equals 1/2 x, you just assume it's y equals 1/2 x plus 0, and your y-intercept is 0. As far as checking these go, how to double check, what you should be able to do is you should be able to pull any one of these points off of your graph, and it should make the equation true. Now, I would never choose the one you started with. Okay, so like for example, for slope-intercept form, that was my first point I graphed. Okay, I would pick a different one. That's not that one. So like this one, as an example, the coordinates of that are 2 and 4. So I should be able to plug into my orange equation a 2 for x and a 4 for y, and it should make my equation true. Let's just look at that right now. I'm going to erase some of this stuff below here, okay? And I'll switch back to orange. So I'm plugging in a 4 for y, so 4 equals 1/2 times 2 for x plus 3. If I do order of operations over on the other side, I get 4 equals 4. I get an equation that's true. Okay, so that's a good way of kind of double checking to make sure you did this whole thing right. Okay, that's the basics. That's the basic method of graphing each of our 3 different types of equations. Again, you've got to know how to identify. Okay, so standard form, x and y on one side. Slope-intercept form, y all by itself on one side, x over on the other. Point-slope form, y and x still on separate sides, but with a number and x in parentheses. Okay, standard form, you're putting in solutions. Slope-intercept form, you're using the y-intercept and the slope. And point-slope form, you're figuring out what x and y would make both sides 0. You start there, and then you use the slope to make more points. Hopefully this walkthrough is kind of helpful. If you have any more questions about graphing, you can consult some of our older stuff or email me with a specific question that you have.